Microscopes really do come in all shapes and sizes, from revealing the structure of tissues to tracking down glowing proteins to capturing living cells in real time. Each type opens a new window into the microscopic world. Today we're going to be breaking down the most fascinating types of microscopes you'll find in the life science research. Hey, it's me, Bruno. Welcome back to Bruno's BioLogs, a space where we explore the frontiers of life sciences together. Look, it's super common for people to come and ask me, what do I do in life? And I tell them I sell microscopes. Keep it short and simple. And then come the follow-up questions, which I'm normally expecting, but the follow-up questions tend to be the same. They say, you mean for high schools? Or like the ones doctors are using? Or my personal favorite is, do you sell them on Amazon? Which I personally didn't know people were doing, but I looked it up. It's true. Try it yourself. So I figured let's clear up the air once and for all, and I'll walk you through the most common types of microscopes scientists use, especially in the world of spatial biology. So let's take a crack at it, shall we? First off, let's start with the classic, bright field microscopy. You shine a light through thin tissue sections, think H&E stains or general pathology work. It's still a staple for understanding basic tissue structures and often the first stop before deeper spatial analysis. Next up, fluorescent microscopy. You tag specific molecules with fluorescent dyes or proteins. Under the microscope, they'll light up like neon signs. It's super commonplace. It's used everywhere from cancer biology to neuroscience to spatial biology. It's really helping researchers visualize and locate targets inside tissues or cells. Confocal takes fluorescence imaging to the next level. And the moment I started working with confocal microscopes is the moment I really started feeling like I was working with microscopy. And that's because it uses laser scanning and spatial optics to eliminate background haze and create crystal clear Z-stack images. Look, it's a really fancy way of saying they get a laser, they shine it through a small hole, and you get great images. It's going to be perfect for thick tissue slices, organoids, or any situation where you want sharp, detailed depth of information. Next up, two-photon microscopy is your go-to for imaging deep into living tissues with minimal photo damage. I first learned about it when I was in college. I had a summer job where I worked in a lab where this PI had his own two-photon microscope. He built it from scratch, and my two rules were not to break it, and for the love of God, don't break it. It's wildly expensive. But hey, it's actually totally worth it, because think of watching neurons fire in a living mouse brain, or monitoring live tissue responses over time. It's a really critical tool for live spatial biology studies. Holotomography is when sci-fi actually meets science. The first time I was exposed to a holotomography image, I had that aha moment. I mean, I've studied cells in biology textbooks, and probably you have as well, but it's another thing when you actually get to see it in real time. They're doing cell things. The crazy thing about it is that it doesn't need dyes or labels. It just uses light phase shifts that build real-time 3D models of living cells. You can literally watch these cells grow, divide, and react to treatment completely label-free. It's a perfect complement to molecular spatial mapping. And hey, if you want to get ultra precise, there's super resolution microscopy. Techniques like STORM, PALM, or SIM push beyond the diffraction limit to visualize molecules at a near atomic level. This is going to be the true frontier territory for spatial biologists who want to map molecular locations with extreme precision. Look, from basic tissue stains to glowing molecules, laser Z-stacks, deep tissue live imaging, and even label-free holotomography, microscopes really are the eyes of modern biology. And in spatial biology, they lay the groundwork for mapping the where and the what of cellular biology. So next time someone asks me what kind of microscopes I work with, all of them. I'm actually totally kidding. I work with one very specific kind at the moment. It rocks. If you want to know more about it, hit me up. I would love to geek out with you over it. Hey, that's it for today's episode. Thank you so much. As always, stay curious, keep exploring, hit me up, let's connect, and I'll catch you in the next episode.